Noha, are you there?
Yes, sir.
So, what should be the answer for question number 39? Yes, you Harshit.
Yes, sir.
What should be the answer for question number 39?
So metal sulfides and carbonate are converted to metal oxide during their extrusion because it is easier to op- it is easier to obtain metal from its oxide than from its sulfide or carbonates.
So, give a reaction involved when zinc is converted by ores. Zinc ore is converted into the oxide form. Will you be able to answer this one? Zinc, if it is roasting is done, so it will be zinc sulfide. When we pass oxygen gas to it and we heat it, it will give you zinc plus sulfur dioxide. And similarly for calcination, if it is calcination is done for carbonate ore, so zinc should be in carbonate form, means ZnCO3. When heated in the absence of air, it will give you ZnO plus CO2. Okay, understood? Note this question number
Yes.
55 in your notebook fast. Note this one. Done?
Yes,
Done
sir.
this one? Okay. So that's all for today. We'll meet you in the next class. Thanks for coming.
Thank you, sir.
Hello everyone, how are you? I'm audible to you everyone. So please everyone, please turn on the camera. Turn on your camera everyone fast. Anam, Sarah, Ram, and Anam. Turn on your camera. In the previous class, we were discussing about the Dalton atomic theory, and we learned the Dalton uh, laws, dynamic postulate as well as law of conservation of mass and law of multiple proportion. So law of definite proportion. Please memorize the definition fast. So that when please memorize it fast. Okay. So these are the postulate of data dynamic theory, and I'm going to ask you, and also the drawbacks that we discussed in the previous class. So memorize it fast. We're going to discuss it in detail. And ask you what are the drawbacks of data dynamic theory as well as the postulate of data dynamic theory. Memorized? Please memorize everyone. When you're done, please let me know. Yes, you, Anam, you done? You memorize the all the postulate? Anam, have you memorized it?
Sir, I have memorized the postulates. I'm just memorizing the last drawback.
Okay. Yes, you Bharti and Hanan, you joined late, so please memorize the this data dynamic theory postulates fast
Yes.
and their drawbacks that we have done in the previous class. Done, you, Hanan? Hanan, Bharti, please turn on your camera. Yes, you, Afreen, speak the postulates. What are the postulates of data dynamic theory? Speak.
All matter is made up of tiny particles called atoms. Atoms are said
Voice
to
is
be
not coming.
invisible
Just a minute.
particles.
Now speak.
All matter is made up of tiny particles called atoms. Atoms are indivisible particles which can't be created or destroyed in a chemical reactions. Atoms of a given element have same masses and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in the ratio of small whole number to form compounds, or the relative number and the kinds of atoms are constant in a given compound.
Very good. Very good. Okay. Yes, you, Bharti. What are the postulate of data dynamic theory?
Matter is made up of tiny particles called atoms. Atoms are invisible particles which cannot be destroyed or created in a chemical reaction. Atoms of the same element have same mass and same chemical properties. Atoms of different elements have different mass and chemical properties. Atoms combine in a ratio of a small whole number to form compounds. The relative number and kinds of atoms are constant in a given compound.
Okay. Okay. Yes, you are. What are the drawbacks of data dynamic theory? Voice is not audible to me. Aram, your voice is not coming.
Hello, hello.
Yeah, it is coming now.
Dalton's theory stated that atoms are invisible particles which cannot be destroyed in a chemical reaction, but later discoveries like the subatomic particles proved that atoms can indeed be divided.
Okay, next, first drawback.
Existence of isotopes. Dalton's theory Dalton's theory stated that all atoms of a matter have different chemical properties, but later the discovery of isotopes proved that
No, he does not say that all metals have different chemical properties. He said that different elements have different kinds of atoms and different chemical properties. They have different chemical properties in different ways. Yes, you, Sarah. What are the drawbacks of data dynamic theory? You didn't attend the previous class, huh? That's right. You memorize the postulate?
Yes, sir.
Okay. What are the postulate of data dynamic theory?
The postulates of Dalton atomic theory are all matter are made up of tiny particles called atoms, and
Atoms are indivisible particles which cannot be broken down, which cannot be destroyed or created in a chemical reaction. Mm. Atoms of an element have identical mass and chemical properties. Atoms of different elements have different chemical properties and mass. Atoms combine in the ratio of small whole numbers to form compounds.
Yes, you
All relative numbers and
kinds of atoms.
kinds of atoms are
Okay.
constant at a given compound.
Okay, very good. Yes, you Anna, what are the drawbacks of Dalton theory?
Indivisibility of atoms. Dalton's theory stated that atoms are indivisible. However, later discoveries like subatomic particles such as electrons, protons, or neutrons implied that atoms can indeed be divided further. No explanation for isotopes. Dalton's theory stated that all atoms of the same element have identical masses, but discovery of isotopes stated that the atoms of the same element can have different masses, for example, carbon 12 and carbon 14. No explanation for isobars. Dalton's theory could not explain the existence of isobars, which are the atoms of the same elements having the same atomic mass. For example, argon and calcium both have the same atomic mass of 40 but are distinct elements.
Very good. Yes, yes, you Hanan. What is law of definite proportion? What is law of definite proportion?
Law of definite proportion.
Okay.
It says that chemical compound that contains component elements are always fixed in a same ratio, fixed ratio.
Fixed ratio minus.
Yes, sir.
Okay. So, what does law of definite proportion states? That in a chemical compounds, elements are always combined together in a fixed ratio minus, irrespective from where it is made up of. Like for example, you can prepare the carbon dioxide gas by different methods. You can prepare the carbon dioxide gas by different methods. Like suppose, suppose if I'm talking that you can prepare the carbon dioxide gas by simple heating of calcium carbonate. When you heat calcium carbonate in the presence of oxygen, so it will give you calcium oxide plus carbon dioxide. You can prepare the calcium carbonate, carbon dioxide when you heat sodium hydrogen carbonate. When you heat it, it will give you Na2, Na2CO3 plus carbon dioxide plus water. You can produce the carbon dioxide when you heat carbon in the sufficient supply of oxygen, it will give you carbon dioxide. When you heat carbon monoxide, CO, in the presence of oxygen, you can get carbon dioxide. So there are different ways to prepare carbon dioxide. But if you are having carbon dioxide, then it means that in this carbon dioxide, every molecule of carbon dioxide is going to have same ratio minus. Okay, means they are going to have, like for example, one carbon atom and two oxygen atom and combined together. Their ratio would be carbon 12. If it is 12, okay. So this is 12 and this is 32. One oxygen atom mass is 16. So O2 will be going to have 2 into 16. We'll get 32. So 12 plus 32 will get 44. Got it? Got it. So we'll simply say here that that carbon and oxygen combined together, they form CO2, irrespective from whether it is CO2 produced by this method, this method, or this method. They all are going to have the same ratio of carbon and oxygen. That is 12 is to 32. You shift it, you can simplify it by further dividing by 4. You get 3 is to 8 is to 11. So this is the simplest issue. For every 3 gram of oxygen, carbon, it will require 8 gram of carbon. Sorry, but it does not mean that you require minimum 3 gram. No, it is not so. If I'm saying that the ratio of carbon dioxide, carbon and oxygen in carbon dioxide, CO2 is 3 is to 8 gram. 3 gram for every 3 grams, you require 8 gram to gives 11 grams of carbon dioxide. But does not mean that every time when you are going to react the carbon, then you need still 3 gram. No, it is not so. If you have 1.5 gram of carbon, half of this 3, then you require half of this 4 gram. If you have 0.75 gram of carbon, 1/4 of 3 divided by 4, then you need 4, 8 divided by 4, you get only 2 grams. You need only 2 grams of oxygen. Understood? It is not so that 3 is to 8. Still the ratio of this one is still 3 is to 8. You can have 0.75 divided by 2, you will get 3 is to 8. How? You remove the decimal, you will get 10 here. You cut it by 25, 25 3 is 75, 25 4 is 100. Still you multiply 3 upon 8. So the ratio should not change. The 0.75 and 2 also have the ratio 3 is to 8. 1.5 and 4 also have the ratio 3 is to 8. 3 and 8 is also having the same ratio 3 is to 8. 6 and 16. If you double this one, you get 6 and 8. Double of 8 is 16. So 6 and 16 is also 3 is to 8. If you cut it, it is also 3 is to 8. So the ratio should not change. The numbers can change, but if you divide 1 by, you cannot say that for every 3 grams of carbon is going to have billions of carbon atoms. You can react 1 carbon atom also with 1 molecule of carbon dioxide. It is not necessary. 1.5 gram is having millions of carbon atoms. This is the ratio. 3 is to 8 is the simplest ratio because we cannot, ratio should not be written in decimals. But it does not mean that 0.75 we cannot take. We can take 0.75 gram of carbon. And for 0.75 gram of carbon, we require 2 grams of oxygen accordingly. Understood? The ratio of 0.75 and 8 is also. It is not so. If we do it like this, like for example, in the next step, if I go like this is C plus O2 will give you CO2. And let's suppose the ratio, simplest ratio is 3 is to 8. And if you take 5 this one and 10 this one, it does not mean that it will give you 15. If this is going to give you 11, 3 gram of this one and 8 gram of this one. If it is going to 11, so if you take the 5 is to 10, it will not give you 15. Because the ratio is not 3 is to 8. Here 5 by 10 is going to have ratio 1 is to 2. It is not 3 is to 8. So they have to react accordingly. The ratio changed, they have to react accordingly. So it does not mean that if you take 3 gram of oxygen and let's suppose 50 gram of 3 grams of carbon and 50 grams of oxygen. So if you react it, it does not mean they will give you 53 grams of carbon dioxide. No. Only 3 grams of oxygen require 8 gram of oxygen. 3 gram of carbon require 8 gram of oxygen. So from this 50 grams, only 8 gram will be used in CO2 formation. And remaining 42 grams will remain in the container. It will not react. Because for further reaction, next 8 gram, we did 8 gram require 3 gram of carbon. So the whole 3 gram of carbon is consumed. We don't have carbon. So if the ratio is fixed 3 is to 8, for 3, 8 will be 8 gram of oxygen. Okay. Understood? Yes or no? So let's have a simple question over it. Put it down.
So is it 40 grams?
Next one. Compound is formed by combination of X and Y. If 10 grams of X combined with 5 grams of Y. It's simple. X plus Y will give you XY. Okay, so this is 5 and this is 10. So 5 grams of X combines with, sorry, 10 grams of X. 10 gram of X combined with 5 grams of Y. So how much X will combine with 20 grams of Y? So if we have 20 gram of this one, how much will this be? This is very simple. You multiply by 4 to get 20. You multiply this one also by 4. Or you can do this one 10 upon X. Means just consider this is X. Will be equals to 5 by 20. Then simple. Reciprocal this one you will get X upon 10. If you reciprocal this one you will get 20 by 5. You cut it you will get 4. And this 10 will goes to that side you will get 40 grams. Correct. Good. Done everyone? Done everyone?
Yes, sir.
Okay. Here we are going to have another question. Okay, if I'm having a simple question here, let we know that hydrogen and oxygen in formation of water, they gives you water and they react together in simplest ratio that is 1:8. So gives you 9 grams of water. Okay. If you have if you have 6 gram of this and 20 grams of this one, then how many grams water will be formed? And which will be consumed first? Which element will be consumed first? We have 6 grams of hydrogen and 20 grams of which element will be consumed first? Done? Tell me that which will be consumed first. Okay, just I am going to give you an simple examples. Like for example, these are the wheels that are being required to manufacture the cycle. And these are the seats. Okay. It is better to write seat than to draw seat. So if I'm saying here that if you have 5 seats and 4 wheel, then how many complete cycle you will be able to make? Afrin, tell me. If you have all other equipment of cycle but don't have the wheel and seat, you went to the market, you buy 5 seats and 3 and 4 wheels. How many cycle you will be able to make? Complete cycle. Yes, you Bharti. How many complete cycle you will be able to make? 4 cycle. Yes, you Anna.
2 cycles.
2.
2 cycles. Very simple. One cycle required 2 wheels, so there are 4 wheels. So here your answer is 2 wheels. 2 wheels. Okay, beta? The answer is now if I change this function, and if I take 5 cycles, 5 seats, and 20 wheels, then how many cycle you will be able to make now? Let me ask how many cycles?
5.
That this is you, Sarah. Yeah, your answer may be correct. Yes, you, Sarah.
Sir, 10 cycles.
For 10 cycles, we have only 5 seats. How can you make 10?
4 cycles.
From 4 cycles. Why? You have 5 seats. Now, for 5 seats, you require 20 wheels. So 10 wheels are extra. Let it be. For 5 cycles, you have 5 seats now. So then you can make how many? You can make 10 cycles, 5 cycles, 5 cycles. Okay. Because you have 5 seats in enough wheel for 5 seats. That is 20 5 for 5 cycles require 10 wheels and they are 20, so they are extra. So it's similarly, if your answer is 5, so it means that your answer you are getting, just concentrate here and everybody. The answer that you are getting here is just based on the limiting reason, the substance that consumed first, that get consumed first. Your answer is according to that. Like here, the wheels are consumed first. Sorry, seat are consumed first. We have extra wheel, but limited seats. So this is in limited amount. This is in limited amount. And this one, here the wheels are for the 2 cycles, for 2 complete cycles. In 4 wheels means 2 cycles. But seats are extra. So your answer is 2 cycles. We can make 2 cycles. So here 2 cycles is because the wheels are limited, so your answer is according to the wheel. Here the seats are limited, your answer is according to the seats. Same question is for this one. If we have 6 gram of this one and 20 gram of this one. Okay, and I ask you that how many grams of carbon dioxide, sorry, water will you form? So first you need to find out that which one is in limiting level, which is limiting, which will be consumed first completely. So for this, you have to multiply this number by this number and this number by this. Cross multiply. So if you multiply 6 by 8, you will get 6 8s are 24. Sorry. 8 4 are 32. 6 4s are 48. 6 8s are 48. Okay. And here you get 20. So where you get more product, that is the limiting reagent. It means 20 gram of oxygen is in limited amount. We have extra amount of hydrogen gas. Okay. So for example, if I tell you only the limiting reagent, like for example, if I ask you Anam, if you have 5 seats, here the seat is in limited amount, and we have excess amount of wheel. If I ask you that how many cycle you can make from 5 seats, so your answer is 5 cycles. Here, if I ask you, if this is in the limited amount and this is in excess, so I remove this one. I only tell you the limited amount substance, that how many cycle can be made from 4 wheels. So your answer is that 2 cycle can be made from 4 wheels. So if I tell you only the limited amount substance, that this is the limited amount substance, then you can get the product. So if I remove this one now, we got the answer that which one is limited. Okay. Now, if there is no need of this 6 gram because it is in excess, we don't require it. So we'll remove it. And we'll write X in place of it. Okay. Because we know that this 20 gram will completely get consumed in the reaction because it is in the limited form. So when you need to find out that how many grams of hydrogen will be required to completely react with 20 gram if the ratio is 1:8. So you put X here. You can write X upon 1, and X upon 1 is equals to 20 upon 8. You can write it like this. If you write this upon this, you can write this upon this. 20 upon 8. You cut it, you will get 4 to the 8, 4 5 the 20. You cut it, you will get 2.5 grams. Means you require only 2.5 grams of hydrogen to completely react with 6 grams or 20 grams of. So this is 2 and 2.5 grams. And how much we have in reality this one? We have 6 grams. So remaining 3.5 grams, sorry, 4, we have 6 grams. No? So remaining 3.5 grams will remain unreacted. It will not be consumed during the reactions. Understood? Understood? Yes or no, everyone?
Yes, sir.
Yes.
So there is no need for the excess. Only the limiting reagent will tell you the product. So when you got both the substance, many times you will get only the single substance. And you need to find out that value of the another one. But sometimes they may give you both the substance, but not in the proper ratio. Like for example, if I took the another example, N2 plus 3H2 react together to give 2NH3. And the simplest ratio of nitrogen and hydrogen is 14:3:17. If I ask you that you have this 12 gram and this one you have 21 gram, tell me that which one will get consumed first, and what is the amount of ammonia gas is going to form? Which will get consumed first? Which one is the limiting reagent?
Sir, 21 grams is the limiting reagent.
21 grams is the limiting reagent. Okay, let's check. This you multiply with this one, you will get 21 3 the 63. This one when you multiply this 14, What you will get? 12 into 14. Means even if it is 10 instead of 14, if it is 10, then you will get 120, which is far product, which is greater than 63. Okay. If it is 14 instead of 14, if it is in 10, then you will get 120, which is the greater. So you will see that the product where you get more product, it is you will get the more product. So it is the limiting region. And this one is excess. So if I remove the excess reagent, because you know that the product is always obtained according to the limiting reagent, which is in the limited amount. So you will remove this one and try to find out that how much grams of hydrogen will be consumed out of 12 grams.
So 14.5 grams will be consumed.
Will be
4.5. 4.5.
4.5. 4.5. Yes. Simple. 4.5. You have 12 grams and only out of this 4.5 grams will be consumed. So the consumed substance will make you the product. Huh? So if only 4.5 grams is consumed and 21 this is wholly going to consume. So the amount of nitrogen that is going to form is 25.21 plus 4.5, you will get 25.5 grams of nitrogen. Okay, got it? In the remaining 12 minus this one, you will get 7.5 grams of hydrogen will remain unreacted, it will not react. This is the law of definite proportion. That in a chemical compounds, elements are combined together in a fixed ratio by mass. It does not mean that if you are going to have extra product, they will combine together. No, it is not so. They always combine in a fixed ratio. The ratio of 21 upon 4.5 is still 14 upon 3. Okay. You cut it, you can get it. You divide this one. Now you divide 7 1 the 7. Sorry, 7 not by 7. You divide it by 3. You will get 7. Sorry, and you divide it by 7. 3. 3 7 the 21 and 3 15 the, and then 15 3 the 5 3 the 15, and then 2. Then still it is 14 is to 2. The ratio of 21 and 4.5 is still 14 is to 3. 14 is to 3. The ratio is not changing. Okay. Got it? Aram, you understood the concept? Yes or no?
Yes.
So let's move to the next part of this one. Now, these are the symbols for the IUPAC naming of some compounds. As we know that atoms, there are different methods, okay, that we use for the, we're going to discuss the mass of the atom, that how we discover the mass of the atom. In the next class, we're going to discuss. So here we have, according to the modern atomic theory, atom is the smallest particle of element which take part in the chemical reactions. In the chemical reactions, such that during the chemical reaction, atoms maintain its identity. So atoms are not broken in the chemical reactions. We have two different types of physics. One is the in which we study the chemical reactions. Another we study the nuclear reaction. So in the nuclear reactions, atoms are broken. In the nuclear reaction, atoms are broken. But in chemical reactions, atoms do not break. They maintain their identity. Okay, throughout the chemical reaction or physical. Atom is very small and hence cannot be seen with powerful microscope. Atom's radius is like approximately this one. Okay. So just a minute. Such that one nanometer. Okay. So let me help you to write this one in a very short words. Let's see. So please note this one in your notebook. Not this one. Atom are the smallest particle involved in the chemical reaction and maintain their identity during changes. Atoms are too small even to be seen even with powerful microscope. Done, noted. So as you know that when we keep on discovering the elements or atoms, different types of elements. So during that times their symbols are important. It is important to memorize their symbol. So there are different ways that scientists do, but later the symbols was that means scientists decided that some of the elements can have means a symbol of an element can be of two letters. First letter should be capital, second letter should be small, or it may have the names not only like for example sodium. Sodium has a English name as sodium, but its Latin name is natri. So that's why we can simply say that there's some metals which are originated and they have different place of their origin. So their names or their symbols are written or chosen from that names only. Okay, so there are some metals symbols that I'm going to give you here. That write the names that of these metals that generally you miss. Okay, you might get confused. So please write them. Other you know everyone like sodium. I am not chosen in this one. Sodium is ending. Okay, so most of you know this one. So please. Potassium, lead. And here is the name for their origins. Done, noted? Everyone noted? Yes, you, Sarah, you also? Okay, so here are the names for their origins. That barium name is symbol is Ba, which is similar to that of first two letters of their English name. But barium Latin name or Greek word is bare, okay? Meanings heavy. So barium is meaning heavy. Cobalt comes from the German word cobalt, meaning gall wings or evil spirit. Okay, cobalt. Then we have copper. Copper is actually CO is copper in English name, but Cu is its symbol name because its Latin name is cupra, derived from the word cupreus. Okay, which is metal from which meanings metal from Cyprus. Cyprus. Okay, Cyprus means a place from where which is called metal from Cyprus. Okay, fluorine, fluorine, Fl. So the first letter from fluorine. Actually, the spelling is fluorine, but it is fluorine. Latin name is fluorine, okay, meaning fluor. Gold, aurum. Aurum means letting, shining and drawn. Iron, Fe. Latin name is ferrum, meaning iron. Lead, Pb, meaning name plumbum, meaning lead. Okay, and potassium means gallium, is derived from the Arabic word al plant ash. Okay, and then silver is argentum, meaning silver. Zinc is German name zinki, meaning tooth like or pointed. Zinki. So make this table also.